This is a review of density calculation from section 8.3 with problems. Our author did not go over detailed problems, so I'm supplementing them here. Notice that density's definition is mass over volume. In symbols, it's D equals to M over V. Things that you need to watch out for. Number one, unit. Unit for the density is mass unit over volume unit. And the two common ones are for liquid, it's grams per milliliter. When it's for gases, usually it's grams per liter. The reason is gas molecules are more diffused. Number two, this is key. When you need to calculate density, you got to have information on both the mass and volume. They are of the thing you're solving for. So you need to make sure of that. Now, this is shown in the example below. It's example 8.9 in our book. I want you to pause the video for a second and take a look at the question. I'm going to go through this quickly. We're trying to get the density of a liquid, that's methanol. And to get methanol's density, you need the mass of methanol over the volume of methanol. Since it's a liquid, the way it's done is you're going to weigh a container, in this case, the graduated cylinder, empty, and then you're going to weigh it with the liquid in it. The weight difference will give you the mass of the ethanol liquid. Okay, so that's why you see here the two mass readings when filled with methanol minus the empty graduated cylinder weight for the mass. The volume is what the liquid reading is. It's this number, not the volume of your capacity. So you need to read the question. The methanol filled to this 1.20 liters. So that needs to be the volume of that liquid. The way I wrote back here in the equation, I stressed that the mass, based on how it's done, is the methanol plus the cylinder minus the mass of the empty cylinder. The volume, I should have said it better. It's actually cylinder reading, not the cylinder volume itself, right? So then you have mass over volume. Now, you don't really have to convert the volume from liters to ml. Your author did it. The reason for that is it's a liquid, so the reading of density is more reasonable if you express it in grams per ml. The number, it makes more sense. If you do it in grams per liters, you'll have a very big number. So the author did a conversion of liters, so then they can cancel, to ml. So this is a volume conversion the author did. Okay, lastly, I want to quickly mention, on the sig figs. I'm going to change the color to green. So when you calculate, notice the first one here is a subtraction. Thus, you follow the rule of subtraction. You keep the least number of decimal places. That's how it's 949.7. You don't keep number of sig figs. You keep the fewest decimal places. Then you have a 4 sig fig over a 3 sig fig, which is ending up, you have a 3 significant figure answer. So you do need to follow significant figure rules. Okay, so this is density calculation. Keep in mind, you know mass and volume, and they are of the thing you're calculating the density for. Going on, using density as conversion factors. So this is a little quick review. In section 1, what we learned was for the same measurement, you could have used different unit systems. Because they're the same measurement, thus they can give you different reading numbers. Thus, there's a relationship between the different measurements. So the example I have here is for the length reading. You could do it in inches or you could do it in centimeters. The relationship between inch and centimeter is this: 1 inch equals to 2.54 centimeters. Because if you know this, you could write two conversion factors. These conversion factors allow you to convert from centimeter to inches or inches to centimeters. You just need to set it up. Now, these are conversions of the same thing. It's just same measurement, okay? okay? But they are different units, right? Yeah. So this is this situation. The new situation, which is in this chapter, is slightly different. I'm going to use a different color. Say I will use blue, okay? Here, we're using density as a conversion factor. So use the methanol we just did. Okay, we found the density was 0.791 grams per ml. What does that mean? That means if you have a 1 milliliter in volume of the methanol, it would weigh 0.791 grams. They are equivalent. Okay, they're the same thing, these two. Okay. Because of that, then you can write two conversion factors. Now, these two conversion factors are different from the ones I just showed above. Okay, these are conversion factors that goes from one measurement, okay, in this case, volume or grams, to another, okay, measurement. And density is the thing that links mass and volume together. Notice these kind of conversion factors, they are kind of a specific liquid even under a specific condition. Remember the example I had in the slide before? It was 20 degrees Celsius. So that was the condition. These conversion factors help you for that specific liquid to go from mass to volume or volume to mass. Now, which one to use, you just make your decision based on what you want to cancel. Okay, so this is the general information. That is a different kind of a conversion. So density is the first time we're introducing one thing to you, and we'll show you something else. Conversion factor approach is a very powerful way of doing calculations. So, whoops. What's going on? I gotta go to the next slide. Okay, so the next slide is a situation. This is question 8.7 in your book. Okay, the next slide shows you, whoops, oh, this is not making sense at all. Okay, good. The next slide shows you a situation where you have water. The volume is 75 milliliters. We know the water's density, which I kind of show here. So the water's density, I'll go back to the red color, is 0.9982 grams per ml. Where that is, this is a sample problem in your book, so you really need to go into the book to take a closer look. That's table 8.2, which gave you density of different things. So here you know the volume, and the question wants the mass. Okay, so how do you set up conversion factor? You start with the volume. You know this is the volume, 75.0 ml of water. You want to multiply a conversion factor that gets rid of ml, that goes to grams of water. This is where this density comes in, because that gives you two conversion factors, 0.9982 grams per 1 ml, or you have 1 ml over 0.9982 grams. Okay, between these two, which one do you want to use? You want to use this one because you want to get rid of the ml. You want to go to grams, right? Okay, so follow significant figure rules, cancel out the ml, you'll go to grams. So here we're using the density as a conversion factor to go from volume to mass. Okay, next question. The opposite. You're given mass and density. We're asking volume. Okay, I want you to take a pause, take a look at the question. Again, you have the density, right? The density gives you two conversion factors. I'll write it again, 0.9982 grams per 1 ml, or 1 ml over 0.9982 grams. 82 grams. Okay, so these are the two conversion factors. How do you convert? You know 25 kilograms and you want to go to volume. Well, this is kilogram, this is gram. They're not exactly the same, right? So the first thing you need to do is you need to convert the kilograms to grams, then multiply this conversion factor. Then you'll go to your answer. So this is how your book did it here. The kilograms first converted to grams. So this does that. Okay, then you're using this specific conversion factor here, right, to go to volume. Your book did do another conversion to go from ml to liters. Now, for a question like this, just the way it is, do you have to go to liters? No, you actually could answer in ml. But because this is my explanation, because your mass is a huge number, the kilograms, so it makes more sense to convert the volume to liters. That's how your author did that. Now, the last side note is, how do you know if you want to do it in ml or liters? Well, it's dependent on the question. For this open-ended question, either way is fine. But if it's the multiple choice question, then depends on what your answer is. So here, I want to give you one more note. Okay. You want to use the unit. Okay. The answers are expressed in. Okay. So for multiple choices. Okay. Good. Okay, so I gave you 3 total examples. One is just a calculation of density. The other is to go from volume and density to mass. The last one is this one. You're going from mass and density to volume. See you later.